You have probably looked out of an airplane window hundreds of times. You see clouds drifting slowly below. The wing stretches out into the distance, and everything feels calm and ordinary. But that window is doing something extraordinary the entire time. It is holding back an invisible force, a force strong enough to tear the airplane apart. That force is pressure. High above the ground, the air outside the plane is extremely thin. Inside the cabin, the air is much denser. Your body needs that pressure difference to survive. So the airplane becomes a sealed container, and the windows become one of its weakest points. At least they would be if they were shaped differently. Early airplanes did not always have rounded windows. Some used square or rectangular designs. They looked normal. They were easy to manufacture, but they hid a dangerous problem. When a structure is pressurized, stress does not spread evenly. It concentrates, and stress loves corners. Sharp corners act like magnifying glasses for force. Instead of spreading pressure smoothly, they focus it into a small area. That area becomes the first place to crack. Once a crack forms, it grows. And under repeated pressure cycles, it grows fast. Every flight pressurizes the cabin. Every landing releases that pressure. This expansion and contraction happens again and again. Metal slowly becomes tired. This process is called fatigue. Fatigue does not cause instant failure. It causes silent failure. Tiny cracks form where stress is highest. In square windows, that stress lived in the corners. Engineers learned this lesson the hard way. After studying damaged aircraft, a pattern became clear. Cracks always started at corners, not in the middle of panels, not along smooth curves, always at sharp edges. So designers changed one simple thing. They removed the corners. A rounded window has no single point where stress can concentrate. The force spreads evenly along the curve. Pressure pushes outward, but the shape guides that force smoothly. Instead of tearing, the structure resists together. This idea is not unique to airplanes. You see it in bridges, in pressure tanks, in submarine hulls. Curves are nature's way of handling force. But airplane windows do more than just have rounded edges. They are not a single sheet of glass. They are a layered system. Most airplane windows have multiple panes. The outer pane takes the pressure load. The middle pane acts as a backup. The inner pane protects passengers from contact and temperature. Each layer has a purpose. Even the tiny hole at the bottom of the window is intentional. That hole controls pressure between layers. It prevents condensation, and it ensures the outer pane does the real work. Nothing about the window is accidental. The materials are chosen carefully. They are strong, but flexible. They can bend slightly without cracking. That flexibility is critical. Rigid materials snap. Flexible materials survive. This is another reason rounded shapes matter. Curves allow slight deformation without concentrating stress. Flat panels with corners resist movement until they suddenly fail. Rounded windows move just enough to stay safe. There is another reason rounded windows matter. Visibility. Rounded shapes reduce distortion. They spread light evenly. They avoid sharp reflections and optical stress. Even comfort is part of safety. When something looks stable, people stay calm. Calm passengers behave predictably. Predictability is part of system safety. Over time, Rounded windows became standard, not because they look nice, but because they survive repeated stress. Thousands of pressurization cycles, years of expansion and contraction, temperature extremes, vibration, all without failing. This reveals something important about engineering. Safety is often invisible. It looks like simplicity. A rounded window does not scream innovation. It looks obvious. But obvious solutions are often the result of painful lessons. Airplane windows are shaped the way they are because engineers learned exactly how materials fail. They did not design for strength alone. They designed for endurance, for repetition, for time. And that is why you can sit next to an airplane window, watch the clouds pass by, and never think about the enormous pressure it is quietly holding back.